Hey guys, welcome to day 4 of circles. Today we're going to be using what we know about finding circumference, so using that circumference formula and finding the circumference or the perimeter of some wonky shapes. What could be more fun than that? Let's get started. First of all, let's review. All right, if we're going to look at this circle down here on your notes, if we want to name the circle, we're going to name the circle for that center point that right there. So this is circle A. And now let's name a radius. There are several. We could name this guy right here, which would be line segment AE. This guy right here, line segment AC, line segment AF, AB. Oh my goodness, there are so many. So go ahead and write those down in your notes. If we want to name a diameter, there's only one. But there's one right here, line segment BE. We want to name a chord. There's one right here, line segment DE. And now let's name a central angle. And there are a few. There's one right here, angle CAE. There's one down here, angle FAE. There's one here, angle BAF. And I think that's it. And then if we're going to name an arc, there are also several of those. There's one right here, arc BC, arc CD, arc DE, arc EF, all sorts. All right, let's get into some problems. We're going to solve for the circumference of A and the perimeter of B. And we're going to use pi equals 22 over 7. Okay, so over here, this is A right here. It's marked in your notes. It's just not marked in my PowerPoint. Okay, so let's start with circle A right here. And we're going to solve for the circumference. So we're going to write circumference equals pi times diameter, and then we're going to substitute in our values. Circumference equals 22 over 7 times 7 centimeters, and we can cross cancel there, and our circumference is 22 centimeters. Okay, that one was easy, right? Now let's solve for the perimeter of B. Now, remember I told you that we were going to use perimeter and circumference interchangeably? Well, the reason we're not using the word circumference on B here is because this is a half of a circle, and it's got this little edge right here that we also need to solve for. So here's what we're going to do. We're going to first solve for the circumference of the semicircle that's up here. Let me trace that again so you can see what I mean. Okay, so we're going to solve for this portion right here, and then we're going to need to come back and we're going to need to add that extra leg, but let's solve for that portion. I have 1/2 circumference times diameter written down there because I'm only finding the circumference of half of a circle, right? So then we'll substitute in our values, 1/2 times 22 over 7 times 7, cross cancel there, cross cancel here, and my circumference equals 11. However, I need to add back in that other leg right there. So it's really 11 centimeters plus 7 centimeters, which equals 18 centimeters. Okay, now we're going to solve for the circumference of the circle when it's in a square. And this is maybe just a little bit of a step harder because now you have to look and see that the edge of the square, which is 20 centimeters, is going to be the same length as that diameter right there. So I'm going to use that as my diameter. So we'll write our formula, pi times diameter, and we'll use 3.14 for pi, and we're going to multiply it by 20 centimeters, and we're going to get 62.8 centimeters. Does everybody see why? You've got your edge of your square over here, and since the circle is as wide as the square, that edge is also the diameter of the circle. Okay, so now we're going to solve for the perimeter of the shaded quarter of a circle. Okay, let's just think about this for a second. We're looking for perimeter here, and here, and here. Okay, this is what I'm trying to solve for, the distance around here to here to here. So I have on here that this right here is 3 centimeters. And since this edge is the same as this edge down here, this is also 3 centimeters. And since this is a radius and this is a radius, that's also 3 centimeters. So first of all, let's find this length right here. Since that's a quarter of a circle, we can just use our circumference formula, pi times diameter, and then multiply it times a fourth, because I'm finding the fourth, or a fourth of the circumference. So we'll substitute in our values, 1/4 times 3.14 times 6. And okay, let's do this. Let's put 6 over 1 there, and then let's cross cancel here, and let's cross cancel here. So now I have 3.14 times 3 divided by 2. So I'm going to just write an extra step in there. Actually, let's do that math up here. 3.14 times 3, and we'll get 12. 3 times 1 plus 1 is 4, and 3 times 3 is 9. And I need to add back in my decimal places. So it's 9.42 divided by 2. So now let's do that division over here. 9.42 divided by 2. 2 goes into 9 4 times. 4 times 2 is 8. 9 minus 8 is 1. We'll bring down the 4. 2 goes into 14 7 times. Bring down that 2. 2 goes into 2 1 time. Okay, so my circumference of just that one portion of the circle is going to be 4.71 centimeters. Okay, let's make this a little bit neater. So now all we need to do is add those other two little legs. So my perimeter is going to equal 4.1 centimeters plus 6. I just went ahead and added 3 plus 3, got 6, or 10.71 centimeters. Okay, now if you have your textbook with you, go ahead and open it up to page 29, and you're going to see a figure that looks like this right here. It's not really a big deal if you don't have your textbook, because I have it on my PowerPoint. But the figure on page 9 shows a flower bed that has the shape of a semicircle, and we want to find the perimeter. Now, we just did a problem like this 2 problems ago. So go ahead and pause the video and go ahead and try this on your own, and then come back and check your work. Okay, so we're going to find the circumference of a semicircle first. So we're going to multiply 1/2 times pi times diameter. We're multiplying 1/2 times pi times diameter because we're only finding half of the circle. So we'll set that up, and let's cross that 2 off and cross cancel there with that 4. So we're left with circumference equals 3.14 times 2. And let's do that math up here. 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6, and I have circumference equals 6.28 meters. Now I need to add back in that 4 right here. So perimeter equals 6.28 meters plus 4 meters, which is 10.28 meters. Okay, so at times you're going to be asked to find circumference in terms of pi, where you don't fill in a value for the symbol pi. Okay, so let's see what that looks like here. We're going to find the circumference of a semicircle in terms of pi. So we're going to use our circumference formula there, but we put that 1/2 in because we're finding only the half of a semicircle, right? So circumference equals 1/2 pi times diameter. And since my diameter is 8, we'll fill that in. Here you can see the diameter right here. Okay, my diameter is 8. And I'm going to just go ahead and multiply out the 1/2 and 8. So I'm going to cross that off, and that becomes a 1, 8 becomes a 4, and I'm left with 4 pi. And that's how I'm going to write that. I don't write the pi first, I write the number first. So my circumference equals 4 pi. Okay, so that's my circumference of the semicircle. If I were to find the perimeter of the semicircle, I would have to go ahead and add back in this leg right here, but that's not what this problem asked me to do. It just asked me to find a circumference of the semicircle. Okay, so we're going to use this in a more complicated problem. We're going to find the circumference of the semicircle in terms of pi. with this wonky, weird thing you have in front of you. This little wavy thing. So let's solve for one circle first. We can do this a couple ways. We can solve for one circle. So let's pretend this circle right here with a diameter of 10 centimeters is not a semicircle, but actually a full circle. And maybe I'll like make a little more effort to make that dotted line look like an, okay, well this isn't any better, but you know what? That's the best I can do. So if we solve for one whole circle, then I'm going to be solving for this semicircle plus that semicircle, right? So we can multiply pi times diameter. So we, just multiply pi times 10, and that would equal 10 pi. Now, since we've got this extra little semicircle over here, that's just going to be an added 5 pi, right? Because it's half of whatever the whole circle was. So that's that whole problem, or that whole thing, is going to equal 15 pi right here. So on your notes, this problem read, a wire is bent to form 3 semicircles as shown. Find the circumference of the wire in terms of pi, and that's what we just did. So here's the other way we could have found it. We could have used the formula for a semicircle, which is circumference equals half of pi times diameter, and then we would have found 5 pi, so we cross cancel there and there, whoops, and we're left with 5 pi, and then we multiply that times 3 because we have 3 semicircles, and we end up with the same thing, 15 pi. Okay, now let's do another problem where we have 2 semicircles with different diameters. So now we've got a wire bent to form 2 semicircles as shown. Find the length of the wire in terms of pi. So what I'm finding here is this. I'm not adding back in this straight edge across. Okay, that's just showing me the diameter. So let's find the circumference of the large semicircle first. So 1/2 pi times diameter, 1/2 pi times 6, and so we'll just cross cancel here and here, and we're left with a circumference of 3 pi centimeters. Now let's find the circumference of the small semicircle. 1/2 pi times diameter, 1/2 pi times 4, and we'll cross cancel again, and our circumference is going to be 2 pi centimeters. Now if we want to find the length of the whole bendy wire thing there, we're going to add those two together. So 3 pi plus 2 pi equals 5 pi. So now you guys can see why we combined like terms when we were in algebra. We just did the same thing. We had a circumference in terms of pi over here, we had 3 pi, and a circumference in terms of pi over here, which was 2 pi. And we were able to add those together to find 5 pi. The reason we were able to do that is because they're both in terms of pi. We could not have added 3 pi plus 2 because they would not have been in like terms. Okay, that would have been bad. We don't want to do that. All right, let's do this problem. A figure is made up of 3 semicircles. Find the perimeter of the shaded figure in terms of pi. Go ahead and pause the video and then come back and check your work. Okay, now this is definitely a more challenging problem, isn't it? We're given 2 semicircles and we're given the diameters of those circles. So the first thing that we're going to do is we're going to actually find the perimeter of this semicircle right here, the big one. And then we're going to subtract, no, we're not going to subtract, we're going to add the perimeter here and the perimeter there. So if we find the perimeter of the big semicircle, we're going to use 8 for our diameter because we can see that by adding this portion, 6 centimeters, to this portion, we get the diameter of the large semicircle, which is 8. And we're going to come up with 4 pi. Then we're going to find the diameter of the medium-sized semicircle. So 1/2 pi times 6, and that's going to equal 3 pi. Then of the small semicircle, which is just going to be pi, and we're going to add them all together, 4 pi plus 3 pi plus pi, and we're going to get a perimeter of 8 pi centimeters. All right, that's it for day 4.